Hey, good morning. Good morning. Penultimate week. All right. So there's only one more week of CS2A. And yeah, well, week 12, let's play it by ear. According to Foothill, we're not supposed to teach on, I think we're not supposed to teach on in week 12. Or I don't, so you can find out whether it's supposed to teach or just introduce new material, because week 12 is the week of exams and they don't want us to introduce new materials to the students. Hey, you got to study this too, right? Master this thesis before you come to the final exam. But I'm happy to give you a class on Tuesday and Thursday of week 12. We won't cover any new material. We'll just go over any stuff. Okay, any material in CS2A or even CS2B, because I looked at my enrollment for next quarter in my portal, and looks like there's a lot of people. Most of you have signed up for my CS2B. That's pretty cool. So I actually look forward to having you all. And by the way, even though CS2B, by the way, is purely online, we're not supposed to have these scheduled lectures like in CS2A, because we have this 8 to 10 block when you're expected to be here, and I can teach you. CS2B is purely online, although, right, I think we are having a lot of fun coding together in class. Yes or no? Raise your hand if you are. Okay, yeah? Okay, good. All right, so when you start CS2B, if you want to continue with meeting weekly to do hack on some project together, okay? So it won't be a formal class. I'm not going to introduce, this week we're going to study overloading operators. This is how you do it. This week, polymorphism. I'm not going to do that in CS2B, because we have all the modules and materials for you to master that on your own. However, we can meet every week. At least once a week. I don't care, right? At least once a week. We can meet every week at a time that is mutually convenient to everybody, and we can work on a cool project. Okay, one or more cool projects. Except like in 2A, we're typically picking projects that will complete in 1 week. One class, right? One class, and then sometimes it spills over, goes to the next class. We wrap it up in 2 classes. But in CS2B, we can work on projects that will span multiple classes. Okay, and not multiple objects in classes, no, multiple lectures. And I was actually thinking of a couple of cool ideas for CS2A that we can do. A 3D cube rotating on your screen. How cool is that, right? 3D cube rotating on your screen is actually pretty cool, but it is not beyond the scope of CS2B. People in CS2B can do it. I can show you how to do it, and it'll just take you 3 or 4 lectures, right? Maximum 2 lectures, maybe 2 or 3 lectures. Okay, we can work on it in class. Well, this is next quarter, and of course it'll just be extra credit. Okay, it won't be, you won't be graded on those things, but you will actually you can get extra credit for those things. So I will look forward to having you all in CS2B again, so we can work on some more cool projects. And for the remainder of this class, this is what we want to cover. We want to cover pointers, okay? Pointers, which is like the cream of CS2A, really, because there's a reason why pointers are not introduced until week 11. And it is because it is very easy to shoot yourself in the foot if you don't know what you're doing with pointers, because you're going to be changing some location in memory. You don't even know what that memory location contains. It may contain a variable that you're depending on in some other part of your program, or it may be a variable that someone else's program. Adam's done something and Thomas's program breaks all of a sudden. And that, well, the operating system makes sure that kind of thing doesn't happen, but still it is possible to corrupt someone else's memory. Even though, you can corrupt someone else's memory and you'll get shut down for it, but sometimes it's possible to do these crazy kinds of things. And in fact, I can also show you how to bring down an entire computer, right? Halfway across the world. So you can log into a computer elsewhere, somewhere in Italy or Africa or some remote corner of the world, and you can log in and basically bring it down. Well, you can't bring down every computer, because really solid sysadmins can make sure all these protections are in place. But even if you have all these protections in place, some facilities that you expose to other users could be dangerous. And if those guys really know what they are doing, they could bring your system down. And for example, actually, that's getting less likely day by day. Even today, I think it's well. We used to be able to do that. I think 7 years ago, right? 7 years, yeah, 7 years ago when I first started teaching at Foothill. 7, something like that. We used to do that in class. In my 2A lecture, we used to log into a different computer like cpp.sh, because I think at that time they were not using Docker containers to run programs that were submitted. Docker containers are self-contained, right? Because it's like when you get a container, like in questing, right? So when you quest, what I do is I take all your code and I run it inside a sandbox container out there out there. So even if you manage to hack your way into that computer and fool around with it, you can destroy it too. Doesn't matter, because that computer is created as soon as you submit your quest code. Okay, and it only lives. That computer is only alive for the duration your quest code is running. As soon as you're done, that computer will destroy itself anyway, right? Like, you know, the Mission Impossible CDs, right? So only as long as you have your code running it. So that, I think, is the approach taken by anyone out there. Most people out there, is that it's not possible to prevent all kinds of hacking. So they say, well, you know what? I'll just give the person a computer. They can hack it if they want, but they're going to shoot themselves in the foot. But even if they bring it down, they're not going to affect the rest of my systems, right? So that is the best approach to take with most system designs these days. And so I don't know if it's possible to bring down a remote computer these days, but we can try it, right, in CS2B. And then the reason for that is not malicious, saying, well, this is how you bring down other computers. No, right? The reason for that is so that when you know how this is done, you will know how to architect your own systems and say, well, you know what, if I do this, someone can bring this system down. So I'm going to make sure that this kind of thing is not possible for someone else to do to my computer. So that is the reason why people need to know how to hack systems, although they don't plan to hack systems, I think, right? Yeah. Because at the end of the day, you can never ever prevent someone from being bad. Right? All these things, law and the police and the communal standards and things like that, they're all there just to knock some sense into us, right? If you really drill down, there's absolutely no way you can prevent someone from doing something bad out there unless you basically restrain them completely and put them in a cell and lock them up or something like that, right? This is a lot of things just run on trust. And a harmonious society is based 90%, over 99% on just trust alone. And so the reason, and that is why I believe that the key to harmonious living or harmonious programming or harmonious hacking or whatever it is not to prevent people from doing shit, because you should know this is how you do shit, right? So I can show you how to do this. But what we should inculcate in students and fellow citizens is be good, right? So be good, because we can't force you to be good, but you got to be good for your own good. Because if you're bad, it's going to come back. It'll come back, and you'll have nasty repercussions, which may feel like you're doing some cool stuff, even though I've gotten better than that person. But ultimately, you'll find that really is no good at all, right? The better way to do it is just to mind my own business, not get in someone else's way, and just do what I can do really well that is fulfilling to me, without hampering someone else's progress, without hampering someone else doing what they want to do, right? So hacking should be, everybody should know how to hack, and people in many countries waste horrendous amounts of money just policing things, when they should basically, I think, use that amount of money in just instilling good sense in people, saying, well, you know what, we can't prevent you from doing this, but if you do this, this is what is going to happen, and eventually you're going to be worse off than. So good sense is better than good law, I think. Okay. So likewise in computer science and programming, it's not like, well, you shouldn't hack because you're going to be arrested, or you're going to be, you do this. this is how you hack it, but don't do it because it doesn't pay at the end of the day, right? What pays at the end of the day is creating something really, really cool that everybody would say, wow, what a fantastic thing that, Sadhvik and Thomas and these guys have done. I'm going to, buy that product. I'm going to go right now, and buy that product, lots and lots of this product because I love it, right? That is where real fulfillment will be, right? And so that is what computer science essentially teaches you, right? So today, what we'll do is we can start coding pointers, and because we're going to be coding stacks, right? Because I wanted to teach. Well, typically week 10 and week 11, I teach stacks and stacks. Yeah, stacks. Yeah, because week 11 is when I do linked list. I think because it's worked out before, and so we can change it if necessary, but I think this will work. So what we'll do is today I'll introduce the concept of pointers, play around a little bit with pointers, coding like we usually do, and then I'm thinking we will implement a stack, okay, a stack data structure using pointers, not the stack data structure that you're going to be implementing in your Quest. Quest 8, you got to implement a stack, but that is a stack implemented using arrays. Using an array is pretty straightforward because a vector is more powerful than a stack. And so you just need to take the vector and take away some of the power of the vector and you get a stack. So, so we'll implement a stack using pointers. And I think that would be really cool. Now we'll also go over some of the advantages of why should we use a stack using pointers, not an array? Why do we do that? Do it this way, right? But today there's strictly speaking no reason at all because you can still get an array on the heap, but we'll do that today, okay? So before we start, if you have any questions, I'm happy to answer those questions. What time is it now? Yeah, 8:15. We'll start in a couple of minutes, right? 2 or 3 minutes from now. And so if you have any questions, please feel free to ask anything we've done so far, okay? Anything we've done so far, or the stuff that is coming up, that is fine. You can ask. Otherwise, we'll look for a couple of people. No, one person will start, okay? One person. Wow, everybody on screen has coded today, I think. Except Will, you haven't coded, right?
Yeah, I don't think I have. I can code today.
Yeah, okay, cool, great. I think, yeah, in fact, Will is the only one who hasn't coded, right? Nemo, Adam, you've coded too, right?
No,
Nemo, you haven't coded?
No.
Okay, so Nemo, you can code next week. How about that, right? We'll do stacks. Adam, you've coded. You said last week, you said you've coded, right? Everybody else is coded too.
As long as there's anybody who still hasn't had a chance, I'd like them to get a chance, but I'm totally down to code more. It was fun.
Great. Because let me read off the names. I see. Alec has coded. I've coded. That's my and Will hasn't coded. Robert has coded. Adam, well, a little bit. Sadhvik has coded. Thomas has coded. Ashley's coded. Nemo hasn't coded. Joshua, you coded. The first couple of classes itself, right? Yeah. And Philip coded like a couple of weeks ago, or and Andrew coded. David also coded, and Darshana. Wow. Okay. Well, everybody who's a regular, essentially. You're not all of you, right? Because there's more people who aren't attending class or today, and some people who are habitually absent too. They're really, they're going to have a really, really tough time passing the class. But everybody who's regular has had a chance to code, and I think you've all enjoyed the chance to code, because learning to code is not. Learning is something you'll pick up, but enjoying to code is something that you have to experience. And so I hope that you all enjoyed your experience to code. Because learning, you'll say, well, I learned it, that's it. But if you enjoyed it after class, you're still going to be coding, right? Even though I'm not there, right? I'm not giving you new projects and saying, this is what you're going to do. You're going to say, well, I saw something that's interesting, I'm going to code it, right? Because you've been bitten by the bug. Got to be bitten. You got to be bitten. Otherwise, it's not going to be fun. Nothing, right? Whatever it is you do in life, you got to get bitten first. So the first, whenever you get into a new field, whether it is acting or music or computer programming, whatever it is, the first even several months, people say, well, the first several months I'm going to pick up the basic skills. Basic skills, yeah, okay, you pick it up on the side. The more important part in the first couple of months in any field you pick up, and that's the ticket. That's the secret to succeeding hugely in any field. Any field you pick, succeeding hugely is picking up the passion for it. And because people always say, and I told this to my CS2C students, because when you get to CS2C, perseverance is a whole lot more important than here. Because here you can afford to do this, 2A stuff, and then you can go back and do other stuff. You do English essays, and this and that, and this, and come back and so on. And sometimes you say, I'm going to put it off and things like that. So you can get by with a little bit of perseverance, but not a lot. CS2C gets harder in 2B, 2C. You cannot pass CS2C if you don't have perseverance. You got to go to bed many, many, many nights thinking that, well, this problem is beyond me. I can't solve this problem. Okay. I'm going to ask someone, I'm going to ask my mom or dad or brother or sister to come and help me, or I'm going to ask in the forums to come and say, what is going wrong? Debug this code for me. And everybody will refuse and say, well, computer science is not for me. You got to go to bed with that feeling. Okay. And say, how can I sleep? I can't sleep thinking I'm a failure. But you got to train yourself to sleep, because the next day when you wake up, you won't feel like a failure anymore, because you've gone to bed thinking that, I can't solve it. And I think your subconscious is not going to be happy with that. Even when you're sleeping, it's going to generate a solution. Or even if you're possible solutions. Next day you'll try it and say it doesn't work. Maybe I'm going to try again. But you would have found it. And so that kind of perseverance. And people always say, how do I succeed? How do I succeed? And always people say, you got to persevere, man. You got to be patient. Persevere. Perseverance is the key to success. I say that is wrong. Okay, perseverance is not the key to success, because it's very easy for people to say persevere. That's how you success. Work hard, you'll get success. But but then the question I'm asking is, yeah, I know if I work hard, I'll succeed. But how do I work hard? That is a real question. You got to say, how do I work hard? How do I persevere? Okay, how do I make it? So I have headache. I have a headache. How can I not have a headache? And you say, well, you can not have a headache by taking an aspirin or something like that. Okay, so take it so that you even though inside your head nothing is really the pain, you've got a wound and your wound is still aching, but you're not feeling the ache. Okay, why? Because your aspirin is blocking that ache sensation from you, so you can focus on other things and say, well, you know what, this wound is healing. I can feel the pain, but this is how it's healing, and I can manage the wound that way. So that way, the key to succeeding in any field in the first few months is to not. You should try to pick up the basic skills, but try to be on the hunt. Okay, you got to be 99% of your brain is basically hunting and scanning the field in that new area that you entered, to find out what is it in this area that is tickling the fancy of all these people. Why are all these people so crazy about it? Why are people being paid millions of dollars to do this thing? And so you got to find out. And that is where the juice is. And once you find out, then the perseverance, that is your aspirin. Okay, once you find out what tickles your fancy, that is your aspirin. Just grab onto it. And that will keep you going the rest of your life. Because anytime someone says that's hard, it's not hard, because I can persevere without feeling the pain. And that is the trick. And so I don't know where we're going with that, but certainly I think you'll have a lot of fun. I hope, right, in CS2B. And I will certainly teach more sections of CS2B than CS2C. CS2C, I'm pretty sure, depending on enrollment, I'll probably teach for a couple of quarters, a couple of spring quarters more. But 2B, I will try and offer more, more until. Okay, so all right, so Will, whenever you're ready, you know what, I'm gonna turn on the heater. It's actually getting quite warm in here. You'll open up just a little bit. Turn off the heater and come back in a sec. Okay, it's not on Alexa. Okay, all right, good. Okay, excellent. All right, so let's put today's class code and everything. Adam. Will's already got these things ready. Will, if you don't mind, can you hit Control+ a couple of times? One time. Okay, yeah, I think that's better. You know what? I should get my other glasses too, because that's better. Okay. Yeah, definitely better. Okay. All right. So today we will play with pointers. We'll play with pointers and implement a stack ADT, right? ADT, uppercase ADT, and then within parentheses, you can say abstract data type. Now, does everybody know what an abstract data type is? Because this is the first time I think this term is being introduced in CS2A. Do people know what abstract data type means? And why is it called abstract? Why is it abstract? Do you want me to tell you why it's called an abstract data type, or can we just proceed?
Could you tell us?
Right. So it's what an abstract data type means is that this data type provides a certain functionality, okay? But you only see the abstraction of that functionality. You don't see the concrete functionality inside. You don't know how it's happening, right? So you get something called a stack, which behaves in a predictable way. However, inside, you have no idea how it's being done because there's a brick wall. You can't see inside. So what you can see is only an abstraction of its function. You cannot see what it does, but you can see that it does something that you want. Okay, so that is why it's abstract. Abstract means you can't see it directly. Yeah, that's what it means, right? Abstract means you can't see it directly, but it's there. But you can see its effect. So abstract, and it's a data type, just like an integer, character. All these are data types, right? Integer, character, double, float there. So you're going to create a data type of your own, and this data type is going to be called a stack. And this stack, again, and we add the word abstract for ADT. Abstract says it's a stack, but you will not know how I implement it. Okay. So for example, in Quest 8, I'm going to implement a stack inside using an array. But here in class, I'm going to implement it using a pointer. And outside, you have no idea which one it is. But you can, get stack functionality. That's what an abstract data type means. So you'll see the term bandied around ADT. Lots of people say ADT. Right? And that's basically what it means. And CS2B is all about ADTs, right? You're going to be implementing lots and lots of ADTs. Very simple. And once you get the hang of what an ADT is and how to implement it, then it'll all be a piece of cake. Because and then it's important for students to get really solid with what an ADT is and how to build it and what are the APIs. The API is an application programming interface. I think it's an abstract, right? What that means is that here is my stack on this side. This is my stack here, and here's my implementation, and you don't know what it is. However, this stack lets you do certain things. You can do functionality A with it. You can do functionality B with it. You cannot do functionality C with it, okay? Because you can do, let's say in an array, you can do a lot of things. But a stack takes an array and hides away a lot of these things and only says you can do A and B. You cannot do C. Whereas with a stack, with an array, you can, with just a naked array, you can do A, B, C. But a stack says you cannot do A, B, C. You can only do A and B. Right? So what that means is that some of the functionality of the vector has been hidden and only a few are exposed. And whatever is exposed are called, application programming interfaces, APIs. Okay. So yeah, unfortunately, there are these jargons that people use. Yeah, many times. There's no reason to use these jargons. So we are not going to use these jargons after this. Okay. I'm just mentioning these. So yeah, and we'll say this data type, on the next comment, this data type will provide the following APIs in uppercase, right? And then within parentheses, again, you can say application programming interfaces. And again, I don't know if that the expansion that I just gave you was correct. You may have to Google it and find out, but I think that's what it means. Okay, application programming interface, right? And the following APIs, and then push, right? Push, lowercase p, push, open close. Push int and push int. A string. Let's say a string stack. Okay. Push string s. No. Push, and then the parameter is a string s. And then you can say you can put a hyphen after that, and at the end of hyphen and say this will take the string s and push it on the stack. This will push string. This will push the string s on top of the stack. Okay, and the next line, you're going to say pop string s. Okay, and no string s there. Just pop. Sorry. Yeah, and this will pop. This will remove. This will remove the top item from the stack. Right, the top item. And then within parentheses, you can say top is the last item pushed. Top equals the last item pushed. Yeah, top is the last item. And then after that, what do we need? Right, top. And this will just this will tell you what the top item is without disturbing it, right? Or without affecting it, What else do we need? Push, pop. And constructors and destructors, you know, and constructors and destructors, and yeah, constructors. And then when we're implementing this, if we remember that, oh, we need another interface that we forgot, and we can go back and add to the comments here. Yeah, okay. And then well, let's also add a note. This tag will be converted. This tag will be implemented using pointers and not an array, unlike in Quest 8, right? Okay. Okay, so that's what we're going to do. Any questions so far? Otherwise, we can you know, start doing this. And is the speed of Will's typing okay with all of you guys? Yeah. Okay. Great. Excellent. Let me get more of you here. Excellent. All right. Now let's go to line 14 and hit enter. Okay. Now here we'll define a. We're going, well, oh, should we play with pointers first? No, well, okay, we won't play with, you know, basic pointers first, like pointers to an integer and so on and so forth. We'll just dive right into this, and in the process of doing this, we'll get a chance to, you know, learn about pointers. And if there's still doubt, I can go to more simpler cases. Okay, so here we'll define the class call stack. Okay, class lowercase c and uppercase s, right? Stack space, yeah, curly brace, and then enter. And put a semicolon at the end of the curly brace. Okay. All right. So here, let's say, oh yeah, before class talk, leave that there. We need one more class above. Yeah, one more. Okay, this is two classes here. Okay, so class. We're going to create a class called node. Okay, node, a capital N. Yeah, node. Yeah, curly brace, enter, and put a semicolon at the end. Now, this node will contain only two things. Okay, it only contain two things, and let's say they're both private. Okay, let's say they're both private. Oh no, in fact, no, let's not make it private. Okay, just make, yeah, leave everything out. No qualification. By default, if you leave everything out, those members can be accessed from the contain class. All right, so it'll have two things. The first thing is going to be string space, and then data, string space data. And we'll call it data. This is what each node is going to store. So what we're defining here is a box, okay? A box that is going to go on a stack. So every time you want to put something on a stack, you got to put it in the box and put it on a stack. You can't just give it. It makes sense, right? Even in a real world setting, if you want to give something, you don't need to package it and letter in an envelope and then you put it in the mailbox. Just like that, if you want to put something in a stack, you can just toss it on a stack. You got to put it in a box, fixed shape, and then put that box on a stack. And so our node is that box. We're creating that box, and every box has got to be the exact same shape. And that's our node, okay? And then the next thing is going to be node space. Just bear with me and I'll explain this later, okay? Node space, and then star, right? And you're going to say next, okay? Next. All right, semicolon. All right, so this is our node class. And in fact, we can put a comment above the node class just to, you know, for people who aren't here today, say this is our container of items that will go 4 items that will go on the stack. It contains the payload data plus a memory address that points to where the next container will be. Does that make sense? That's all it has. So it's a box, and that's the reason it has to go in the box. Okay, if you just put the basic the naked item on the stack, then there's no way you can get to the next one. However, we're going to put it in a box, and that box, like a chain letter, says this is the item, but the next item is going to be located there. Okay, so it has 2 things in there. That's why it needs to go in a box. So all right. So it contains the payload data plus a memory address that points to the next. Yeah, okay. All right, that's all. Now let's go to our stack class. Let's go to our stack class. Okay. Now here we're going to do a private colon. Can you unindent private so that it lines up with class? Great. Okay. So on the next line, you're going to say private node, private node star stack. Yeah, node star stack. Yeah, thank you. Lowercase stack. Lowercase is different from uppercase, right? So lowercase stack. All right. What else do we need? In fact, you know what? Yeah, I think that's probably all we need. If we need something else, we'll come back and do these things and change it around. Now let's do some public methods now. Public methods. Yeah, thank you. Great, excellent. So let's do the constructor first. And you say constructor is just stack, open, close. Stack, open, close. Yeah, all right. And then what we want is we want a destructor, but we're not going to do a destructor right now. We will not do a destructor because I want to do it without a destructor and then show you what happens. Because we're dealing with a heap, and it's going to be like critically important as you go into 2B, because you're dealing with a heap. When you go in, when you start your program, what happens is that you create variables, right? You create variables A, B, C, X, Y, Z. Some of these variables are local variables inside your block. Yeah. And those variables are created on what is called the system stack. The system gives you a bunch of memory locations to use, and you can create all your variables in there. But that is called the stack memory. But that is limited. It's like, a few hundred megabytes. That's all. When every program gets a few hundred megabytes. However, most computers these days, they don't have megabytes of memory. They have gigabytes, terabytes of memory, right? So if you want to have a program that does some real serious shit, right, you can't be limited by just the memory that's on a stack. You got to say, well, I'm going to process a memory. I'm going to process a movie, and the movie is like several gigabytes long. So I need all the memory that you have in your heap. And the computer also has a lot of heap memory, which is far, far bigger than what the program has been given. And the operating system says, all your local variables, you can put it in there. And if your program just works with that, that's fine. But if you want more memory, then you can ask me, and I'll go to the heap, which is the main memory of the computer. And the main memory, terabytes of it. And you tell me how much you want, I'll grab some of that and give it to you. All right. So unlimited memory is available to you on your system, but you got to ask for it. Whereas on the stack, it's already given to you. That's the difference. However, it comes with a catch. If you ask the operating system, give me some memory from the heap, huge amounts of memory, that means that you are now responsible for telling the operating system when you're done with the memory and say, you gave me that big blob of memory and I've done stuff with it and I'm done. Now you can take it back. Now, if you don't do it, and this is the critical part where lots and lots of programmers get stuck, even not just students, right? Programmers get stuck too. And we have lots of tools in the system that help you get to the bottom of, where did my memory leak, right? So, because if you ask for memory, use it and forget to give it back, that memory, the operating system will think that memory is locked up, right? That memory has been assigned to this person and they're still using it. Even though you're not using it, that memory is locked up. Other people can't use it. And even you, later on in your program, you want more memory and you go and ask, and you say, well, you know what? And the operating system will say, I had to give you a lot of memory. I don't have any more memory. Yeah. So you run out of memory. And the reason, and that is called a memory leak. Okay. A memory leak is when you take memory from the operating system, but forget to give it back. And that is the most common error faced by C++ programmers. And that is the reason why, lots of people, develop all these other languages like Python and Java and Rust and these things that are coming up, because people say, programmers shouldn't be forced to deal with pointers and memory allocation because they are really, really intricate things. And, things could go wrong and memory could be leaking and you won't know and things like that. But I don't know, right? Sometimes it may be good for really, really experienced programmers. But as you're learning to program, you should never go directly to Rust or Python. I'm not just kidding in that way. But you should never go to a language that automatically manages your memory for you. Okay? When you're learning to program, you have to learn to program in something like C++ or assembler. Okay? And the reason for that is that you will know how everything is done at the lowest level. You will know the costs associated with using certain data structures. Because once you know how to take memory and give it back to the operating system, Then you can say, well, now I'll use a Java or a higher level language, which will do that memory management for me. Now, the reason why, and that's why, you can go out there in the in Silicon Valley, and you can scan, right? And based on my experience only, right? And this is from several years ago, because I haven't been, out there for a long time now. Most of the people you hire, or most of the people that you encounter as programmers, I think, who know how to use these tools, right? So Python, for example, right? So they know how to use dictionaries in Python. They know how to use these, tools and data structures in Java. Java, I think Java has generics. You can have, hash tables and everything for you, and linked lists. They know how to use these things, and they architect systems. But if they don't know how to implement what they're using, so because implementing a linked list takes a bit of effort. Implementing a hash table takes a bit of effort. You can skip that and say, I'm just going to go and learn how to use a hash table. No, because if you just go and say, I'm going to use this data structure without knowing how to do it, then you will be completely unaware of the costs associated with the different operations. Unless you actually, learn the data structure on your own without, there are a lot of programmers out there who don't know the costs associated. And so they'll just use a Python dictionary, a JavaScript dictionary willy-nilly, saying, oh, I can do this, I can solve this using dictionary, okay? But the dictionary is the last thing that a person should be using there, because the dictionary is extremely expensive for what they're trying to do, right? And those kinds of things you'll know, right? You'll know that when you employ someone and they say, how do you solve this problem? Yeah, you can solve this, even on a whiteboard, right? Using a dictionary, and they get the solution, but you'll know, right? That's the solution they took. That means they don't know how the hash table works, because they're using something in a very inefficient way. They'll solve the problem, but it'll solve it in an inefficient way. And the risk, and I think I mentioned this before to you, the tragedy with inefficient implementations is that it'll go unnoticed, right? Most of the time it'll go unnoticed, and they may even net rewards for the programmer. Say, oh, what a great programmer, he saved our department, and, our entire team got, a reward for completing this project. But the problem is that even though it worked, it did it inefficiently, and that inefficiency will not come to the surface until that program is taxed. Okay, so when that program says, oh, it works, everything, our QA engineers are happy, we'll release it into the wild. Okay, now, say, all right, Microsoft does this release, and this new Bing release out there in the world. Okay, and they'll never do that. And it goes through hundreds and hundreds of review cycles and make sure that every little, thing is taken care of. These big companies, right? And so, because the little things that work in your office and inside your company mysteriously fail out there, because they cannot handle big data. When millions of users are hitting it, the hash table will basically crap out, because the hash table is not the right thing to be using for that kind of structure. But by the time it's out there and scaled out in a big way, the programmer that wrote it is gone, right? Maybe they got fired, or they went to a different job. And so that is why it's super duper important that programmers need to know the ins and outs before using these higher level languages that provide the more fancy data structures. You need to know how these things are done, and that is the reason why we are going to be doing these things. Okay, and in 2B also, right? You're going to be implementing in 2B. You're going to be implementing so many data structures, and that by the time you're done with it, you will actually have a solid feel for what is expensive and what is not expensive. Yeah. Okay. All right. So that's so we won't do a destructor. Put a comment there saying we're deliberately avoiding a destructor to run into memory leak and see the leak. That's fine. We nobody wants to run into a memory leak, but this is only for memory leak. I think good. All right. So public. So the public methods should have push, pop, and top. The same signatures as up. So for push, you can say it returns a bool. And push will return a bool. Yeah. Pop. Pop can also return a bool. Pop can also return a bool. I think we may have to change some of these signatures later, but and then top will return a string. Top will return a string. Okay, those are the only three we have to implement, and it's pretty straightforward, I think. Okay, so now let's go ahead and implement the constructor first. Okay, first let's implement the constructor. Yeah, so we can implement. Go to line 32. Yeah, there you go. Implement. Stack double colon stack, right? Stack double colon stack. I'm starting to think that this whole thing is very simple now. We may be done in the next 30 minutes. Okay, what we'll do after that is we'll try and come up with a game, right? We'll try and come up with a game or something interesting that we can do using a stack, right? So we'll implement the stack and then use the stack later on if we have time in this class to make a game out of the stack. And today is Tuesday. Oh, we have another class on Thursday. Yeah, Thursday we'll already start moving from a stack to a linked list. Yeah, okay. I think that's good. We have lots of time. All right. All right. So here, all this is going to do is essentially create the very first node that is ahead of the stack. Okay. And in fact, you know what? No, in fact, let's not create the very first node. The very first, the constructor, all that the constructor needs to do is simply set next to null. Set next to null pointer. That's all it needs to do, right? Next equals null pointer. In fact, you don't do star next because star next means contents of the memory address, right? We want to say the memory address itself is a null pointer. The memory address itself is 0, not the contents of the memory address. Yeah?
Next is a member of node, not stack.
Oh, yeah. What do we have? Yeah, stack dot next, right? Stack dot next, I think. Hang on. Oh, hang on.
Isn't it a different operator than the?
Oh, yeah. Geez. Well, one sec. Oh, not next. Stack equals null. Then stack equals null. Stack equals null pointer. Okay. Yeah, I think that should do. Thank you, Adam. Yeah, I think that'll work. Yeah. All right. No, that's all. That's the constructor. So all the constructor does is basically say, this is a stack and it's got a pointer to a node, and the very first pointer is empty, meaning there's no containers at all on the stack. That's what the constructor says. Okay. So now we're going to go to the push method, right? The push method is going to take an item and push it on the stack. Yeah. Push and then string s, string s parameter. String s parameter. Okay. All right. So what do we do here? The first thing that push is going to do is create a brand new node. Okay. It's going to create a node, and that node is not on the stack. It's going to be on the heap out there. So the way to do that is to say node, lowercase node, lowercase. Oh, yeah. What you did was right. Node space node. Yeah. Equals lowercase node. The second node is lowercase. Yeah. Node.
Sorry, the autocorrect. My bad.
Call it node p. Node p. Call it node p. Node p. Node p. No, node p, node node space node p. Oh, I'm so sorry. Well, I was confusing you. Node space node p equals node space node p equals. Because I want to, yeah, the variable, I'm calling the variable node p instead of node because it is not a node. It is a pointer to a node. This distinction is like super duper important. Just make sure that everybody is 100% comfortable with this. Okay. Node is different from node p here. Node p is a pointer to a node. But node is actually the node itself. And right the difference, yeah.
It's a node right now because there's no, it's not using the asterisk. It's not.
Oh, yeah. I think you forgot. He had the asterisk before, I think. Yeah, put the star. Yeah, okay, great. No, and then you can just say new, and then open parentheses. Oh, no, new node, semicolon, that's all. New space node. Right, so that will, because the compiler knows the structure of the node object, you've defined it up there, right? The node has got 2 things in there. It's got the payload, which is the data, and then the next pointer. It's got it in there. So the compiler knows when you say give me a new node, it'll say, well, you know what? It's got a pointer that's 8 bytes, and it's got a string that's 24 bytes, maybe. All right, a string is basically a string class is just 24 bytes because inside of that it'll have a pointer to the actual string, right? So 24 plus 16, 40 bytes. All right, so when you say I want a new node, the compiler will ask the operating system, well, the code will ask the operating system, because you're asking new, right? It'll say, hey, operating system, give me a 40-byte chunk of memory somewhere, right? And it says anywhere. You don't have any idea where it's going to be. Because depending on when you run the program, depending on how many other people are on the computer, depending on what processes are running on your computer at the same time, you have no idea where that memory is going to be. So you're just saying to the operating system, just give it to me. And it'll take 40 bytes of memory somewhere, random place, and will give it to you saying, well, you know what, this memory address, 34FA7, right? Some random memory address out there. That memory address is the start of your 40-byte sequence, okay? And that's what it gives to you. And from that point onwards, the operating system will take those 40 bytes and mark them, okay? And it'll say, these 40 bytes belong to Will, okay? It'll say, Will. Okay, so those 40 bytes have been allocated to Will, or, the person who's running this program. And henceforth, after that, until Will says, I don't want those 40 bytes, if someone else says, Adam starts coding and says, give me another 40 bytes, the operating system will know, right? Oh, I can't give Adam any part of the 40 bytes that have been already given to Will because that's got Will's name on it, okay? So it's allocation. And the operating system has a memory manager. It'll take care of these things for you. And it's a whole lot faster because that's done at the hardware level than a Java and Python and all, because those languages have to use a garbage collector. And garbage collectors are actually programs, and they have sophisticated logic in there. And the garbage collector needs to keep track of how much memory is being used, what chunks of memory are being allocated to which program. And also, even worse than that, the garbage collector needs to track which bits of memory don't have anything pointing to it. Meaning that I gave this memory to Adam. Now Adam's done his program and he's gone. He's gone off to New York or somewhere. Okay, so that memory is still out there, it's hanging. And if I don't take it back, that memory is lost. It's a leak. It's a leak. So inside of that program, the garbage collector not only needs to handle the giving of memory, but it also needs to monitor those locations, or monitor references to the location, saying, but I have to make sure that things that are out there that are not being accessed by anyone, I can give back to the operating system. That's and think about it. It is like having a child at home that eats candy and just tosses wrappers around, right? I got a candy, I'm gonna eat my candy, toss things around. And because indisciplined child, okay, indisciplined child just eats and puts trashes there, tosses trash everywhere. That means they've got a servant, some paid guy like at Mar-a-Lago or somewhere, coming around behind you saying, oh, I'm sorry, Your Highness, you dropped a wrapper, I'm going to take it and put it in the trash can. If you got someone like that following you around, making sure that any trash you drop is picked up and thrown in the trash can, that is called a garbage collector. Okay, now you can imagine already, garbage collectors aren't free. You got to pay them, right? You got to pay a garbage collector. So like that, if you're going to use Java or Python, you're going to have a program called a garbage collector running in the background. Whether you like it or not, you're never ever going to get 100% of the CPU. Some percentage of the CPU is being taken up by the garbage collector, okay, which is constantly just using those cycles to look for memory that has been allocated but is now not accessible by anyone anymore. That means that memory was taken, and the person who used it took off, okay, didn't care to give it back to me. That means I got to be careful and find out, and you can already imagine that is, tell me if this is true or not, okay? If someone has memory, they're done with it, give it back to the operating system, say, I'm done, okay? Is that more efficient and cheaper than having the operating system saying, well, they don't have to give it back to me. I'm going to keep looking everywhere for all pieces of memory that have not, right? That are not being accessed. That I'm going to take and give it back to the operating system. That is what you have following you around in Java and other languages. And you can already see what kind of a hit you're going to get. Now, the irony, I don't know if you've done big systems. Eventually, maybe some of you will implement big systems in Java and other languages too. You'll see these systems sometimes running smoothly and squeakily smooth for a long time, right? Sometimes it's working, and all of a sudden, you'll see the program just freeze, seize up. And it's freeze up, right? And it's not doing anything at all for, but it's not like locked up permanently. It's not doing anything at all like 2 seconds or 3 seconds. You see, like you're driving at 100 miles per hour on a highway, and all of a sudden you got to stop to 0 and then accelerate again to 100. You can feel that bump. That's what you get when a garbage collector kicks in all of a sudden, and that happens all the time, right? I've had this happen. Maybe the garbage collectors have improved since the time I've used them. But back in the day when I used to write these Java programs, they'd run beautifully, but all of a sudden the garbage collector kicks in and the whole program grinds to a halt. And then people will say, oh my gosh, there must be a bug. Something is wrong. And then we just try to look at it, and then it just eases up, unfreezes, and starts working again. And that is a sign. The garbage collector is kicked in and says, hey guys, stop your work. I'm going to be cleaning up now, okay? And then after it's done cleaning up, you can start, because all the CPU is taken up by the garbage collector. Now, so you see how much is wasted there? In C++, you don't have that wastage Because, not because C++ is a powerful language. It is because C++ makes you a disciplined programmer. Okay, just like a disciplined child at home that knows not to eat candy and just keep tossing candy wrappers all over the place. Yeah, so just like that, a C++ programmer is disciplined, saying, well, I take that, I'm done with it, I'm going to give it back. And once you and people say, you know, don't do C++, don't learn C++. Sometimes I don't know if people really say that, because they say, oh, in C++ you got to handle memory management and shit like that. Okay, but you know, right? It's not like that at all. It's in the beginning, it looks intimidating, having to manage your own memory. But after a few times doing memory management on your own, it just sinks in. And so you'll just do it automatically. When you ask for memory, it'll be there in your mind. So, well, you know, when am I done with it? When am I done with it? I got to give it back. And you'll do that automatically. It's like training a person at home to say, just be clean, so that you don't, you know, tasks don't pile up and then you got to do all of it at once. So you just, and then initially they'll say, oh no, Dad, you know, I got to do this, I got to do this, I got to do this. But after a few weeks, they're just doing it even without you telling them, and they don't even know, right? And you say, hey, well, that was really cool. You cleaned up after yourself. And I say, oh, did I clean up after myself? I didn't even know, right? Because it's all gone into the subconscious now. It's become automatic. And that is how automatic it will become. When you do memory management on your own, then you won't be complaining and saying, well, you know, I don't want to use C++. I'm going to be using Java because I'm not, you know, good enough to do memory management. No. So now you can do C++. Then, you know, Unreal Engine and all these things. You do C++ code, right? And you'll be able to very easily program in these environments and do some kick-ass stuff. Okay. So now new node, and on that line, you can put a comment saying this requests some request, you know, you say, all right, request size off within parentheses, say node, size off within parentheses. No, size off is one word actually, because it's from C, not from, yeah, size off and node. Okay. And then space bytes. No, node and then close parentheses, space, bytes from the operating system to store a single node on the heap. You know, in fact, you can put the whole thing on one line and put it above that. Yeah. No, inside the function, but above the new statement there. Yeah, I think that looks better. Okay, and push. All right. Now on the next line, you're going to say, oh no, on the next line, no, after the new. Enter one more time. And now all you have to do is say node arrow, node dash greater than, that is the arrow, right? And then don't have spaces around this, because even though it's an operator, yeah, here's the thing, okay? That's why there are no hard and fast rules, because if there's a rule that says you have to have spaces on both sides of the operator and force it, like, you know, there are some places where you have to obviously break the rule. And so that's why in this case, programmers typically break the rule. They don't have spaces, okay? And say node arrow data equals S. Oh, and then it's a node P, not node. No, node P. Yeah. Why is it still underlined? Why is it still underlined? What does it say?
You need
Oh,
a
it says
star for node
inaccessible.
P.
Oh, do I have
Oh,
to?
that is so funny.
Do I have to do that?
No.
Okay.
Put it back to where it was. Now, the funny thing is, I thought, and I'm so sure, I was so sure that this was the case, that if you didn't explicitly qualify the members in a class, they are what is called, oh, they are protected. That's why you can't access them here. No.
Should I switch this to public?
They're either
Make
protected or
them public.
private.
Make
They're not
them
public.
make them public.
Yeah,
One
you
way
need
is to make them public, and the other way, by the way, is to, and I'll show you the other way here inside of comments. Okay, just copy that entire node class and paste it right under. Copy the node class and blank line and paste it one more time, but put it under, paste one more time, blank line above it, and then put the whole, change the word class into struct. Now lowercase s, yeah.
Gotcha. Yeah, sorry.
right?
And
Get rid of the word public.
Public, yeah.
That is, and then put the whole thing in comments. Put the whole thing in comments. Put that thing in comments, right? And say this is another way of declaring the node class. Struct is a struct is, or you can basically a struct is basically a class in which everything is public by default. And you can say alternate way of doing it, right? Alternate way of declaring a node.
And then since we don't need the node data structure outside of this sort of stack implementation. So like,
Yes.
optionally, we could, I'm not saying we need to, but optionally we could put that struct in the private section of the stack declaration. And that
It
does
is.
the
It is.
same
It is.
thing.
It
You
is
mean
already.
here?
Oh, you mean
Yeah,
the
Or he
class
means
declaration
inside
itself.
here. Yeah.
Yes, 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 yes. So what Adam is saying is that already the node object, the node pointer is private, which means people can access it. But what Adam is saying is one subtle level above what we're doing is that even the declaration of the class itself, people don't need to know what a node looks like. So take that, the definition of the class, no, the declaration of the class, and even that you can put in the private section. And that is called, what? And that is called an inner class. Let's not go into the inner class right now. You're going to have to implement an inner class in CS2B, the first quest, or maybe even in quest 9. Let's not go down the road. But yeah, Adam raised a very valid point. And we won't do that right now. Adam, is that okay? We're not going to do that as an inner class, but we will have the node as a private object. The node is a private object, which meets 50% of what Adam said. Really, right? Yeah. Because the node is private inside of our stack class. Other people can access the node that way. Okay. All right. Cool. And then you're going to say, yeah. Okay. All right. Now here's the tricky bit. Now this container is going to go on the stack, and the next member of the container, where should the next member point to? Right. So this is a string that got pushed on top of the stack, and inside of the container, inside of the box, there is a data that contains a string. Also has a next. What is under? What is the one that comes after that? What item should next be pointing to? What is the next item of the node going to point to at this point? Can someone tell me that? It points to whatever was previously on top of the stack. Yes or no? Yeah.
Like what's beneath it in the stack?
Yes.
Okay.
What is beneath it in the stack?
Okay.
Was that you, Andrew?
Oh, that was me, Will. But
oh, that was you, Will. Right? Yeah. It was whatever was beneath it on the stack. Essentially, a stack is a last in, first out data structure, and it's often called a LIFO, L-I-F-O, LIFO, last in, first out. The last thing to put on the stack is the first thing that you can take out, right? You can put a lot of things on the stack, but you can't request something from underneath. You can only take things in the reverse order in which you put things on, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you cannot remove 1 until you remove 10 first, 9, 8, 7, 6, 5. Yeah. So whenever you put something on the stack, its next thing is just going to be what was already on top of the stack. Yes or no?
yeah.
Okay. And what was already on the top of the stack? It is basically just hang on. Yeah, it's basically our stack. We have a pointer called stack, right? In our stack, where is it? Yeah, node star. Yeah, I think it's line 32. It's half obscure. Yeah, there you go. Node node star stack. That is our pointer to the very top of the stack. Very top of the stack. That's what it is. Okay. So now a new item has come in. We've taken the item, put it in a box, and there's a next inside of that, next pointer inside of that. All we need to do now is take that next pointer and connect it to what was on top of the stack. Yes or no? And then one more thing, we have to do one more thing. After we connect that to the top of the stack, we got to tell the stack ADT, well, you know what? Your top is not what you thought it was anymore because I pushed one more item. Now your new top is what I just pushed in. Yes, that's all. Now, it's very simple dance. This is the simplest dance. If you learn dancing, this is the first thing. You know how to do this, right? So this is the very simple thing. And you got a question, Adam? All right, okay. So, and you're going to be doing this so many times, okay? So many times and so many different contexts. So it is worth it to get thoroughly comfortable with pointer manipulation like this, right? Imagine that pointers are basically just these strings, or these things with arrows, and you take them and stick them elsewhere and point them, right? So you got to take this and point it there. That's all. Okay. So on the next line, you're going to say node P arrow next equals stack. What you had, right? Stack. And is that all we have to do? Oh, no.
Then we have to point top to the other, right? Or
yes, and stack needs to be stack equals node P, right? Now this on the next line, line.
Sorry.
Yeah, so on the next line, stack equals node P. Now, this is the part that in the past, students have, when I used to have office hours, this is the part, office hours in on campus. This is the part that most students used to come to my office being confused about, those two lines, and it's only two lines. And they say, I don't understand this. You're saying A equals B, and then you're saying B equals A. Well, how does it even make sense? And after that, aren't A and B equal? That is what most students get confused by. You're saying, next equals stack, and then stack equals next, or node which contains next. So and you got to wrap your mind around this. And the only way I find that has worked with greater than 90% accuracy, success, is to just take a piece of paper and a pencil, just draw it out. I can guarantee, right, that you will not require more than half of that piece of paper, and you won't take more than 10 minutes. You have to draw it and take that line that you drew, right, erase it, point it elsewhere, okay, and then stack, point it here. You got to do that. You got to do exactly those three lines by hand on a piece of paper. If you do it by hand on a piece of paper one time, that will set you up for the final exam, and also have the incredible side effect of removing, getting rid of tons and tons of bugs you may potentially face in Quest 9 and later. Okay, you have to get completely, thoroughly familiar inside out with this thing, right? So yeah, the following two lines are core. And please, and you can say try do it on paper or something like that, right? Draw it out on paper and convince yourself, because this is something you're going to be doing like millions of times in your career as a programmer. Right? So you draw it on paper. Yeah, draw a diagram. Yeah, draw it on paper. Okay, good. Okay, I think that is basically our push. That is all. Now let's do our pop operation. Okay. Stack colon pop. Okay, all right. Now our pop, all our pop has to do is, and our pop, right? Can you pop things from an empty stack, right? If the stack has nothing in it and you say pop, is that do you accept? Will it succeed? No. Yeah, there's nothing in the stack. So already now, I'm sorry,
we didn't do returns in the push statement. We just sort of did the functionality.
Oh, thank you. All right. So return true. Yeah, return true. You know what? Do we need to return? Push can basically be void. Push can, because I don't know if it makes sense to return. Can someone tell me if it makes sense to return anything from push?
I don't see it ever failing. I don't see how it could ever fail. I don't think it
can fail, right? Yeah, good. So I think that's the kind of reasoning we should do, right? So we look at it, is there any way it can fail? If there's no way it can fail, just make it void. Unless it has to return.
Or should pop also be void, or no?
No. However,
because if it's empty, then
let's ask the same question that Adam asked. Okay. Yeah, let's ask the same question that Adam asked. When can pop fail?
When the stack is empty. Okay.
Yes. Okay. So let's make sure that pop returns bool. And that means the pop is going to return bool. And then if stack equals null, if stack equals null pointer, just return false. On the next line, you can just return false. No, you didn't braces, because people don't use braces for it's an early return, early exits. You can basically get rid of the false, and then indent in, and indent.
Oh
the
yeah,
return.
yeah. Sorry.
Good. All right. So now we know the stack is not empty. Now what we have to do is we can just have to unlink the top element, just the top element. Okay. So we're going to say node star, no, uppercase node, star, element to delete, right? Element underscore to delete equals stack. Now, again, point of confusion. People may say equals stack. Is that the whole stack? No, right? In fact, let's make if you don't mind, let's clean up our naming so that it's easier. Okay, let's not call that variable stack. Double click right there. No, double click right there, and then refactor. Right click now. Right click on the double click and say rename. There must be rename somewhere.
Refactor.
Yeah, refactor.
Okay.
Now you can change it. It'll change all the stacks.
Right.
Call it the topmost element, right? Call it topmost element. Yeah. Oh, why didn't it change? Why didn't it change? It actually didn't do a refactoring. Why didn't it do a refactoring?
Let me see.
Yeah. And you have.
Yeah, it says no refactoring is available, or that's what it said. Wait,
This is VS Code.
Yeah. Wait, there's definitely like a quick hotkey, but I don't remember what it is.
No. Now backspace right now. Just backspace one. Click inside and just backspace.
Control F2 is the.
No, when you had the rectangle around it.
Yeah, I mean it just. But okay, yeah.
No backspace.
I don't.
No, without clicking refactor.
It won't. Dude, I tried.
Wow.
I don't know. I'm not sure.
Okay.
So you said
now you
command
got to change it
F2.
by hand, I'm afraid. You just say top element. Top element.
Wait one
Top
second.
element, and then
Okay, there we go. Thanks, Adam.
Oh, there you
I got
go.
it. I got it. Adam, it's command F2. But anyways, what do we top element?
Top element. Yeah.
Okay.
There you go.
Cool. Thanks,
Okay.
Adam.
Yeah. So element to delete equals top element. Yeah. On the next line, you're going to say top element arrow next. Top element arrow next equals top element arrow. Hang on. So if that's gone, top. Top. Oh yeah, no, not top element arrow next. I'm sorry. Okay. Now, now what you want to do is basically say stack equals. No. Oh my God, I'm like totally confused, screwing with you guys. I'm sorry. Okay, let's. What we want to type there is we got a handle on that. So all we need to do is say top element equals top element arrow next. Okay. On the next line. Now you can say it is now safe to delete element, right? It is now safe. This is safe, right? You can say safe to delete on your blank line and then say safe to delete. Safe to delete now. Okay. You say delete space top element. Oh yeah. Bummer. Okay. No, you can't do that. Because top element is now the top element arrow next. No, delete element to delete. Sorry, delete element to delete, not top element. Element to delete. Okay, all right. That is our pop method. I can't believe it took so much time to write pop, but return true, lowercase t. Okay. Now, does anybody have any questions about what we just did? We took this is our stack and it has lots of elements. We said the pop needs to delete the last element, the top element. So I'm going to grab onto the top element. Now my stack is the top of my stack is not this one anymore, but the top of my stack is now whatever this guy was pointing to, which was a guy underneath. So I'll take the top of the stack and make it point here. Now this guy can go. Now it is very important that it's done in this order. If you delete this guy before the assignment, then you cannot get your handle on the next guy. Yes? If you get them, if those two statements are out of order, your program will crash. Yes or no? Right? So Adam is the only one, Sadvik is the only one now. There's only two people. Okay, Will, is everybody on board there? if you reverse those two statements, your program will crash because you've freed something and then you're trying to access something that's inside the freed thing. You can't do that. You can only access things before you free them. So before you free them, grab onto the next, then you free it, and then you can delete this guy. Yes or no? Is everybody okay with this? Okay, good. Because I don't want you to, because that's a very nasty bug. It's a very nasty bug, and it'll take you tons of time to find. If you have it in, some complex code out there, it'll take you a long time to find. So it's better to get used to this right now, right? So top is like super duper easy. String. Oh, I see. It returns. I see. What would top return if what would top return if the stack is empty? All right. What would top return if the stack is empty? These are important questions. It's not programming questions. What would top return? Because we said top is going to return a string. But what if the stack is empty? What is it going to return? Right. So we got to ask those questions, right, before you implement something like this. So how can we handle that situation? How can we handle the situation when top has to return the top element of the string, but the stack is actually empty? There's nothing on the stack. What would you do? What are common ways you can think of in which you can handle that situation? Because there's many ways in which you can handle that situation. One of them is called throwing an exception. Okay, throwing an exception is, we'll do that in CS2B, and it's a pain. In fact, even today, I try my best never to throw exceptions. Well, yeah, not never. There's some places where you have to throw exceptions, especially in constructors. But people try and avoid throwing exceptions unless they absolutely have to. So that's one way you can solve it. How else can you solve this problem? Where you're trying to pop something from the stack, and then the stack is empty. What would you do? So you can think of it this way, right? You have the stack person here, right? And you say to that person, give me the top of your stack, and you're expecting them to return a string to you. Okay, you're expecting them to return a string to you, and they have to return a string. There's no way they cannot return a string, okay? Because the compiler will enforce it. Otherwise, the code will not compile. So they have to return a string, but there's no way they can return a string because the stack is empty. There's no string to return. What will they return? Take a guess, okay? We have time. Take a guess, because these are the kinds of problems you're going to have to solve, lots and lots of them, right? And it's very simple, and whatever approach you're going to come up with now to solve this is the exact approach you're going to take later on with other situations that are very similar to this, okay? So this function has to return a string, but there is no string to return. What can you do?
Either an empty string or a null pointer.
Well, you can't return a pointer
Or-
because a null pointer is a pointer, isn't it?
Well, they're just null though, right?
No, but it's not a string.
Huh?
You can only return a string. So if you
Oh,
return a
that
null
doesn't work.
pointer,
No, doesn't work like in Java, huh? Okay.
no, even in Java,
Yeah, in Java,
yeah.
you-
In Java, it only works in, by the way, in Java, the only reason it works is because even though you think you're getting an object, you're never ever getting an object. You're only ever getting a pointer to an object. So
Right.
Java uses pointers, except that you don't see that there's a pointer.
Okay, so
Okay,
then
in Java, everything is a pointer. Every object is a pointer.
so
So
just
that is the only reason it works in Java. It never, even if you say it's going to return a string, it's only going to return a pointer to a string. It's never going to return a string. So let's not talk about Java there. So this has got to return a string and it cannot return a pointer. So what can you do?
just empty string.
Okay, good. All right, so that is a very good guess. Now, the problem there is that what if I wanted to push an empty string on stack? Right? What if I wanted to push an empty string on stack? And then I try and do a top and it tells me an empty string, then I'll just end up assuming the stack is empty and trash it. Yes? So then, typically how people handle the situation is define what is called a sentinel. Okay, a sentinel. Have you encountered the word before? Sentinel, right? A sentinel is basically a signal. Okay, a special data item that is guaranteed not to be valid. Okay, so in fact, let's see. Hey Google, define sentinel.
Here's the definition of sentinel: a soldier or guard whose job is to stand and keep watch.
Okay, all right. Totally not what I was expecting. Okay, but a sentinel is essentially is just keeping watch. Well, let's try Alexa. Alexa, what does a sentinel mean in programming? Different question.
From Honkiet.com. In programming, sentinels are values that are used to indicate the end of a loop or process.
Yeah, okay, this is more reasonable. Let's try the same question with Google, okay? 'Cause I'm sorry. Okay. Hey Google, what does a sentinel mean in programming? Hey Google, what does a sentinel mean in programming?
According to Wikipedia, in computer programming, a
Okay.
sentinel value is a special value in the context of an algorithm which uses its presence as a condition of termination,
Okay.
typically in a loop or recursive algorithm. People
All right.
also sometimes.
Hey Google,
ask,
stop.
What does sentinel mean?
Thanks. All right, so that's what a sentinel means. A sentinel is a special value, okay? A special value that the user of the class sacrifices, okay? The user sacrifices one value among the infinite number of values that variable can take and says, I thereby, in order to have the luxury of using your stack, I hereby give up my right to treat the empty string as a string. In other words, I will never use an empty string of my own when I'm using the stack, which means I know that if I get an empty string, the stack is empty. So who proposed returning an empty string before? Was it Thomas or Andrew or Will?
Emo.
Nemo, right? So Nemo's solution is one of the most common solutions people use, is to say, except it may not be an empty string, okay? It may be a special string, like, within double quotes, you may say underscore, hash bang, sentinel, hash bang, and so on and so forth. Some kind of complex string that only you know, that other people won't know. So chances are very, very low that someone would actually try and push that string on stack. Yeah, so that is what a sentinel is. Now, that's what we'll do here. We'll do that. So go to Google as open. We'll just type, type junk. Okay. So go to your go to the stack class. Go to the stack class. Up in the stack class, where you, and let's define a const. Oh no, we can actually do it. All right, okay, so we'll do it here and then we'll adjust the stack class later, okay? Is Will here, by the way? Has he taken a break from the keyboard? Will, are you here?
Sorry, I'm back. My bathroom's
Hey.
getting remodeled. I was hoping.
No worries, no worries. No, I was just checking because I was talking to you. All right, good. So what we'll do here is, if, so inside of top, you're gonna say if stack equals null pointer, if stack equals double equals null pointer.
Oh, sorry. If
Yeah.
Is
No,
that what-
lowercase,
sorry.
lowercase. You have that right? Yeah.
Well, I
Lowercase
think we
stack,
changed the
double
name of
equals.
it though. Oh, W equals.
Oh yeah. We changed the name.
Yeah,
I'm sorry.
top element. Okay.
Top element equals null pointer. Thank you. Right.
Okay.
So then you're no semicolon on the next line. You're just going to say return, and say stack double colon sentinel. Stack double colon all uppercase sentinel. Okay. Now let's go to our stack class on top. Let's go. No, stack class. Definition of the stack class.
Yeah,
Definition of the stack class. Where you had class stack.
Oh
right on
yeah.
top.
No, but sorry.
Yeah.
Oh, okay. Oh, we haven't added it. Yeah. Okay.
All right. So under the private.
Oh wait, sorry. Stack private. Okay.
Yeah, under private, you say const. You don't. That doesn't have to be const. Let's say string. Yeah, string. If it's const, you'll have to initialize it. I don't know how a const string can be initialized there, but we'll have to look it up. But we'll not do a const there. Just say string. String, and then say uppercase sentinel. Yeah, and a semicolon, and then put a comment there. Put a comment on that line saying, look up on Google how you can have a string constant in a class. Okay, it's something very simple. You can figure it out. Okay. Yeah. Okay. Right. So in your constructor now, where's your constructor? Where you said
Wait, you mean here?
equals null
The
pointer.
top.
No, constructor, stack colon stack.
Oh, okay, yeah.
Yeah, under the assignment to top element, next line, you can say sentinel equals, and within double quotes, just punch a whole lot of junk, okay, including special characters and everything, right? Okay, semicolon at the end. Okay, now the chances that someone else will come up with the exact same, someone else out there in the real world who's using a stack class wants to push that string on stack is very low. Yes or no? Okay, so it is a reasonably safe bet to use that as a sentinel, right? So you can actually put a comment on top of that too, right? We want to choose a sentinel. We want to choose a sentinel which has a very low chance of being actually used by a user. Yeah. Actually.
Oh, sorry.
Yeah. Okay. Actually used by user. Actually pushed on a stack. Actually pushed on a stack is better. Pushed on the stack. Yeah. Okay. Now, does that make sense? Now here, in your top now, you can basically say, just if and you don't need stack double colon sentinel. It's a method, isn't it? So it'll just take it. All right. So if the stack is empty, it is going to return the sentinel. If it is not empty, all it's going to do is return a top element arrow data. Okay. I think that is it. What time is it? Wow. Okay. Well, we got time. That's basically that is. We just need to do the destructor of this class. We're going to do main now. In our main, we're going to use the stack, and then we'll also create the destructor to make sure that there are no memory leaks. Okay. Hey, is this a Mac or a PC, Will?
Yeah, it's Windows.
It's a Windows machine. Okay. Yeah. So you don't have Valgrind. I was trying to see if I could show you the memory leak. I don't know if you
I
got
could
Valgrind installed.
send the source code over to someone who has Mac.
No.
Or no.
It doesn't matter. No, not worth it. You find it.
This
Okay.
should
All
work
right.
on
So
Mac. This should be fine on Mac.
It should. Yeah, I'm pretty sure. But yeah, this will run definitely. I'm pretty sure. Okay.
If statements still have one equal sign instead of two.
Oh, thank you. Who was that, by the way?
Nemo.
Nemo. Thank you, Nemo. All right.
Both my ifs.
Um,
or am I good? Is that the only one?
One
Yeah,
more.
I did both. Yeah.
Cool.
Excellent. All right. So let's go to our main method, and we're going to create a stack. So say stack space my stack. Okay. All right. Now let's do something here. Let's create a loop of. Let's create a loop. So just say for while true. And basically while true meaning you have to enter at the loop and then hit Control-C to end or something like that. Okay, while true, blank line above that, and also true within parentheses. Yeah, thank you. All right, so here's what we want to do. Prompt the user for a name and push the name on the stack. Prompt the user for the name for a name. Push the name on the name on the stack, and also, oh yeah, we want to do one more method. I think it's a very easy method. Okay, and we'll do that. Yeah. So here's what we want to do. We want to prompt, take the name, push it on the stack, and also print out the stack. So that in our main, we're going to play with the stack, and also after every push, we're going to play with the stack. Okay. Actually, let's do it. Since we have time, let's do it a slightly more sophisticated than that. You can say, what do you want to do? Push, pop, or top? Well, what do you want to do? What do you want to do? Push, pop, or top? Okay. All right. A space after that. Space after that. Yeah. And you don't need an endl. You don't need, because you're going to be accepting input right there. So now you can say get line from the user input, get line user input, cn comma user input, and you need user input. No, cn comma user input. and then you need to declare user input inside your while loop. Inside your while loop, you can say string user input. No, string user input.
Yeah.
Yeah, and a semicolon at the end and blank line after that. Okay, now after that, one more blank line, and you can say if user input equals push, you can say do push. Double equals push. Yeah. You can say do underscore push, and then pass the stack as a parameter to that. Okay, pass the stack as a parameter. You say open parentheses. Stack.
Okay, yeah.
No,
Or it should be
my stack.
Yeah, sorry.
Okay, semicolon, and then on the next line, else if user input equals pop, do pop.
Is it do? It should do that. Sorry.
Yeah, do underscore push.
Oh, it is.
Yeah, we're going to write those functions. We're going to write those functions.
Okay.
Yeah. So do pop my stack,
Do I?
and then likewise, and then top also. And we'll do one more, okay? And then if user input equals dump, okay? Or print, user input equals print. Yeah, print. You can say, yeah. Okay, now let's make this a bit more user friendly, okay? Just a little, oh, yeah, you need an else, one more else, default, okay? Default. Else, you say cout. I don't understand, try again. I don't understand, try again. Because if they type something that is not any of those, you need to tell them, right? I only understand those guys. Okay, try again. Yeah, thank you. There you need an end. Okay, now let's try and make this a little bit more user friendly. Make all the comparisons, capital P push, make them all lowercase, right? Push, pop, top, equals push. You got equals push.
Oh,
you say equals top. And then the thing you can do is make sure that user input is also all downcased, right? If someone can Google and find out, is there a single function, a C++ function to downcase string? Okay, there's one in C. I don't know if there's a function in C++. If there's so someone can Google and find out and let us know. Otherwise, we're gonna.
They can input either with a capital or a lowercase, right? And it'll still work. That's why. It'll just.
I'm sorry.
Are we doing the down case so that if they were to say
yes,
push with a
yes,
capital
yes,
P, it'll just be okay.
Yes. So that is called canonicalization, right? So later on, when you do machine learning and data engineering and all, you'll come across a term called canonicalization or data normalization. Normalization is basically just taking data that could be in many different forms and just condensing it all to one form that everybody could have spoken, right? So like BBC, British English, BBC normalized English to that particular dialect. So that normalization of data is making sure that it conforms to something that we know exists. So after the in fact after the get line, hit enter, hit enter, and one more enter, open a comment there, and say to improve the user interface, to improve the user interface, consider downcasing user input. Consider making user input all lowercase, so the user can type in mixed case. Does that make sense? Okay, good. Excellent. So now what we need to do is that you see that function called do print. We actually had a function called do print, and that do print function we got to implement. Okay, and in fact, what we'll do here is rather than say do print my stack, we're going to change that. Say my stack dot do print. Okay, my stack dot do print. My stack dot do print. Yeah. Okay, now do print is a method that we need to. In fact, we don't need do print actually. My stack dot print is fine. My stack dot print. Okay, so let's go and include the declaration of my stack.print. My stack.print. Yeah, there you go. And say void print. And then we need to define the method also. So after yeah, top, we can say void stack : print. Yeah, open close. And then here's what we'll do, right? How do we do this? Can we print them all? Yeah, we'll print them one per line. I think that's cleaner because if the stack is really long and it'll wrap around and all. Yeah, we'll print them one per line. Okay, so for here's what we'll do. So you say actually that's correct. Good. So this is a very nice and we have a chance to look at one more pattern of coding, and this is it's a kind of for loop which is very unique to C++, and you'll see it lots and lots of times. And so that pattern is good, right? So for node star p equals what did we call it? Top element, yeah, top element, right? Semicolon, and then node p is not equal to null. Then p is not equal to null. No, yeah.
Oh, and
No. I'm sorry. After the semicolon.
oh, okay.
Oh no, wait a sec. Your for loop. Go into the for loop.
It should be like
Yeah,
this.
no.
Okay,
Inside the for loop.
Yeah.
No, I'm sorry. Let me start again. Okay, I confuse you totally. For node p equals top element semicolon space.
Oh,
P is
yeah.
not equal to null. Yeah, p is not equal to null. Null
Not
pointer.
equal to what? Null pointer. Okay.
Null pointer. Yeah. Semicolon space. P equals P arrow next. Okay. All right. Okay. Now this form of a for loop you will not see in any other language. Okay, because no other language has pointers. I think, right? Python, Java. You don't see pointers. Actually. Well, yeah. All right. Okay. You can have linked lists and you can have the structure in Java too. Okay. So I'll take that back. Right. But this is very unique in C++. And right. So all we need and the first double equals is just an equals, right? The first one is just a simple equals. Okay? Right. So here, all you're going to do is just say cout double less than cout left shift p arrow data, and then end out. That's it. Okay. And then you don't need braces for the for loop either. Get rid of the braces. And then above the for loop, yeah, you can say cout. No, you can just say cout, no comment. Cout, left shift, stack, your stack is, or colon, your stack is colon endl or something like that. And then endl. You don't need a space because that'll be invisible. You don't need a space after that. Great. All right. And then at the end, after the for loop, you say end of stack. No indentation. Go back. Yeah. Now you can say cout end of stack. Okay, endl. Okay. Now what we can do is put 3 hyphens before your stack is, 3 hyphens before, and then 3 hyphens on a blank line, and then same thing with end of stack too. No, not new line there. Yes, yeah, a space. I'm sorry, it's a space, and then just before end of stack. No, before. You'll see this because when you print it out, it look cleaner. Okay, all right. So that's all. Now, now we have these 3 simple methods to implement. Let's do push, right? Let's do push, and you say void do push, right? And then it takes a stack parameter. So you can say no. You can say stack. Now you're going to say the stack is going to get passed by reference. You don't want a copy of the stack. You want the actual stack to be given to you. So you're going to say ampersand, and say STK or something like that, STACK or whatever. Yeah, that's fine. Okay. All right. So all this function has to do is prompt the user for a string and push it on the stack, right? Take whatever the user gives you and put it on the stack. That's all it has to do, right? So see out, yeah. Ask what do you want to ask? What do you want to put on stack? What do you want to push on stack? Yeah. Question mark, and then see in user input like before. Oh, get line. Yeah, see in user input. Yeah, semicolon. String user input. Semicolon. And blank line after the declaration. No, blank line after the declaration. After, not before.
Oh, sorry. Okay. Oh, yeah.
That's fine. You don't have to apologize. All right. So after the get line, and go after the get line, hit enter. Now here we're going to do something very important, in my opinion. Okay. So you're going to say if user input double equals sentinel, uppercase sentinel. Yeah. On the next line. And this will have braces because it's line spec.
Sentinel's a member of stack, not
Yeah. Thank you. And I think it's a stack. No, it's a stack dot, not stack double colon. No, stack dot. Your variable, your the variable that's passed in. Lowercase stack. Yeah, oh yeah. On the next line and braces. No, why did it say sentinel is? Why is it underlined?
I think it
It's
is.
Maybe you need to save it.
inaccessible. Maybe it's private.
No. I think it's just stack dot. No. Stack dot.
Okay.
Is it a public static?
Oh no. Do push. Oh, I see.
Go to the declaration.
Oh, yeah, I haven't added do push,
Do
right?
push is not a stack method. It's do push is a main method. Okay. Okay. Let's not mess with it. Let's not mess with it. Okay. All right. So let's get rid of that. If these things are right. Okay. Now all you need to do is just say my stack dot push user input.
Oh, wait. Sorry, what? Say it again.
The push. User underscore input. Okay, now put a comment above that line, blank line above that, and put a comment above that. Yeah, thank you. That's good, right? Blank line above that. And then one more blank line. Put a comment there. At this point, you may want to check. You may want to sanitize. You may want to sanitize user input by checking that it is not equal to sentinel. Because if it is equal to sentinel and the user is trying to put something on the stack that is equal to the sentinel, then the class should actually warn the user, right? Hey, you're trying to push something that has meaning to me. I won't let you push it, because if you push it, everything under that is gone, because your top will screw up. Yes. So that is why we need to guard there, and that you can do that yourself. Okay. Now what's the other one? Do pop. Okay. Now do pop. Yeah. Okay. There you go. Now here. Now we have to remember that pop returns a bool, isn't it? Pop returns a bool, doesn't it? So here you're going to say if stack dot pop, if oh yeah, it takes a parameter stack.
Yeah.
Stack ampersand stack. Okay. All right. So if stack dot pop on the next line, because stack dot pop returns a bool, you don't have to say if stack dot pop equals true. Yes. You want to say if true equals true, right? If stack dot pop return, no, you can basically say here, this is not a stack method, right? You can basically say return, no, you can say cout successfully popped one element. Successfully popped the top element. Right? I enter. Yeah. Right.
Yeah, okay.
I think that's it. Oh yeah. Else. You need an else. Else. Cout. You can say stack was empty. Okay, that's it. Right. So what else do we need to do?
Let's do top.
Do top, do top. Okay. And again, what we'll do is well, you know what, it'll be much nicer if we have one more method, and it's a really simple method, and we're going to use the method now, and we'll
Is
implement the
empty.
method later. Okay. Yeah, yeah.
Yeah, I
Who
was gonna
said
say
that?
we keep doing Will, because we keep doing this whole
Yeah, all the time. Yeah, thank you, Will. Okay, so just use if empty there. So if stack dot is empty, if stack dot is empty, you can just say cout cout stack is empty, and then return right there. Or you can do else after that. Yeah, you can semicolon else stack dot oh yeah, oh I see, you need to, yeah, you know, else you can say, yeah, that's fine. Else top of stack equals cout top of stack equals cout top of stack equals no equals, you can just say equals, right, space, and then left shift. Yeah, is it my stack? No, it's just stack dot top, and then enter. Is that it? That's all, is it? Is that all? Oh, we need to
Yeah.
implement is empty.
Yeah,
Is
just
empty.
is empty.
So let's go to the class definition here. Let's go to the class definition. And is empty is a simple method, so we can actually do that inline. This is called an inline. Okay. So so you say bool is empty. Okay. Open close space. And within braces, you're going to say no on the same line, Yeah. Yeah. And there you're going to say return top element equals null pointer, double equals null pointer, double equals null pointer. Yeah.
All right.
And then semicolon after that. Now close brace. One sec. Okay. I thought there was one more thing that I wanted to do here. No, curly brace. You can, that function is done.
We did
Yeah,
not.
put a blank line above that and put a comment, you know, put a blank line above that, and one more blank line and then a comment, right? This is called an inline definition, right? This is called an inline definition. Look it up. Yeah. Inline meaning that the definition is, you know, you got the declaration and then definition follows later on. Here, sometimes this function is so simple that you take the definition and put it inside the class def itself, right? And that is called the inline definition. Okay, so let me take a quick look, okay, just to make sure is empty, return top element equals null pointer. Yeah, I think that should do it. I believe that is it, guys. I think if you compile it and run it, hopefully there are no compile errors, because, you know, we had like a million pairs of eyes debugging this code as we wrote it. You know, everybody, Nemo and Adam, and everybody was calling out all these little bugs. So I think if we compile it, there'll be no compile errors. Famous last words. No compile errors? Did it have an error? Oh, it actually ran.
What do you
No,
want?
no
to
compile
do?
errors?
Push pop or top? Yeah. Should we try?
Wow. Okay. So first of all, we got to pat ourselves on our backs, because, you know, we wrote a program that is more than 150 lines and it compiled on the very first go. Okay. No compile errors. But obviously it's because so many of us are coding together and so many eyes looking at it. And this is, and it's a very good sign for our class. Okay. In our class, why is it so important that we wrote a program and we compiled it and it compiled without any errors? It is important because it is corroboration. It is evidence of the fact that it is not just me who's coding. All of you are coding. Okay. And so how many classes have I taught? How many classes have other instructors taught where they're just coding? And at the end of the day, students had no idea what the hell was coded because nobody was following the code. Right. And here we have 100% super duper evidence that everybody's actually following the code. Everybody's actually coding. That's the only reason why there are no bugs, because I can't see, you know, honestly, even with these classes, the font size and everything, I can't see everything. Okay. So the fact that there are no errors in there is actually a testament to the fact that you are all coding with me and you're all following the code, you know, step by step. That is absolutely super duper cool. Okay. Now let's do the print, right? Oh yeah. Okay. We need to do one more thing. Push pop top or print. Okay. One more. Okay. Here, let's run it again.
Even if it runs,
You got to stop it.
I
and
don't
run.
think there won't be any problems. Even if it compiles the first
Control
time.
C.
Thank you.
Sorry, Robert.
Oh, you got to compile it and run it, right? Yeah. Okay, great. So print the stack and it should say empty, right? Is it? There you go. Okay, is that the expected behavior or not? We always have to try these things out and make sure that's the expected behavior. Okay, now let's try and push will on stack. Okay, will. So push will. Okay, now print the stack. There you go. Will.
Nice.
Okay, now let's push Adam. Adam and Nemo and Ashley and Robert. Let's push all of you guys on stack. Okay, I'll call the names out. Robert, William, Ashley, Nemo, Andrew.
Good.
Sadvik, Alec, David, Thomas, Philip, Kenneth, Leo. All right, so you got a lot of typing to do, but I think it's worth it because we got time.
I don't know if I got everyone.
Yeah, go ahead. You know, whatever.
I also think I
you wanna
misspelled Sadvik.
That's okay.
I wish I could.
There you go. Is that the
update it.
right thing? Right?
Yeah. that's
Leo
the
was
right
the
order.
last guy pushed. Yeah,
Yeah.
and he's right on top of stack. Okay. Now let's do a top of stack and it should say Leo. Yeah. Okay,
Yeah.
now let's pop the top of the stack. Let's pop the top of the stack. Okay, now do a top. Yeah, print again. Leo's gone. Okay, cool. All right. Okay, now keep on popping and let's see what happens if you pop past the end of the stack. Now print now. Oh, you should go two more.
Yeah. So okay, now it should be empty, right? Okay. And
It
pop
should be
again.
empty now. Yeah.
Okay.
Yeah, cool. Okay, so all of those things work. However, there's one problem here. The problem is that now if you end the program, the memory that was allocated in all those pushes, you created new cells, right? They're still dangling around there. And so that's a memory leak. So what we want to do now is implement what is called a destructor. A destructor automatically kicks in, right? You don't have to explicitly go and destroy the stack and say, I'm going to I took all these elements, I'm going to give them back to the operating system. No, you can actually C++ gives you a hook, right? Java doesn't give you a hook, right? Other languages don't. I think I don't know. That's Python. Java, there's no hook. Okay, you can't say when I'm going to create an object, when the object goes out of scope, when the object is destroyed, I want this code to be called. You can't do that in Java. C++ gives you that hook saying every time you create an object, the constructor will be called, and when the object is destroyed, either by you or because the object fell off the stack, you know, it's a local variable and it went out of scope and got destroyed. In either case, special code that you wrote will be called. Okay, that's called the destructor. Now we're going to do that destructor. We're going to create that so that we don't have any memory leaks. Yeah. Okay. Now, yeah. Okay. So now put the destructor. So the destructor, the signature of the destructor is special again. It says the same as a constructor, except it has a tilde sign in front of it. Okay, so same name as a constructor, say stack, and then put a tilde sign in front of it.
I'm trying to find
Yeah,
the tilde
tilde?
key.
What is it?
I'm looking for the tilde key on my keyboard. That's not the top left where it normally is. Right?
Yeah, top left on my keyboard too.
Oh, it is. Okay.
There you go.
My bad.
Right?
I just
Yeah.
don't have I have custom keycaps.
Yeah.
Anyways.
Open, close, and then enter. Open, close, and enter. Yeah, enter. And the reason I say enter is because no, the semicolon and enter.
Okay.
Sorry. Yeah. Many people you'll find have constructors and destructors. That's one paragraph, and then all the methods, separate paragraph. And sometimes even those methods may get split up, right? This method does this chunk of methods do these. So they have paragraphs in there too, but we'll do it this way. Okay, all right. Now let's do the destructor after. Yeah, there you go. So say stack, double colon, tilde stack. Okay, now yeah, enter. Now the destructor is like super duper. The logic in the destructor is a little, well, we'll do it and then you'll understand. Okay, so let's put a comment on top of the destructor saying the destructor is critically important because it takes the memory given to us and returns it to the operating system when a stack object is destroyed or goes out of scope by itself. Otherwise, you'll have a memory leak. Otherwise, the program will start getting fatter and fatter and fatter. That's a memory leak. You know, how many times have you fired up a program like Chrome, right? You fire up Chrome, and how many, you know, many times, most of us don't kill our browsers, right? When we start a browser, the browser's going until the next time you reboot your machine. Yes? I don't, well, I mean, for me anyway, I don't, you know, I don't start a browser every time. So when I start a browser, it's there. So,
Sorry,
so,
can
but
you repeat that middle part? I just missed it. Sorry. When,
which one? Oh, yeah,
it's,
yeah.
when
Returns it to the operating system when the stack is destroyed or goes out of scope,
Okay, thank you.
or goes out of scope. Right. On the next line, you can say otherwise. Yeah. Oh, yeah. That's fine. That's fine. Okay. And then blank line after the comment. Oh, no, not blank line. Go into the function now. Into the function. You don't need a blank line there, but yeah, that's there. You go. Right. So tab in. Now here you're going to say for same kind of loop that you had in the other one. Where's the other kind of loop? Oh, you can just type it in again. No, practice. Don't look at it. Don't look at it. So for node star p equals. Now uppercase node star p equals whatever that thing was, top element. Okay. Semicolon, p is not equal to null. Yeah, and then p equals p arrow next. Yeah, on the next line, and no semicolon, no semicolon. Do you have a semicolon there? Okay, right. Yeah, there you go. We need braces. Yeah. All right. So here you're going to say you're going to say yeah, node star element to delete. Node star element to delete. Node star element to delete. Equals what do we call it? Top element. Yeah. Enter. Now you can say top element equals top element arrow. Oh, you know what? Yeah. Oh, wait a sec. No, my logic is basically messed up here. You know, we could do it the easier way. We don't need to. We've already used that pattern for loop before. We'll just say while. So yeah. Oh no, wait a second. Oh hey, wait a sec. Okay, I'm so sorry, guys. As this happens when I'm thinking about this now. Element. All right, you get the top element. All right, so let's. All right, the equals top element. We'll do it using a while loop, okay? We will do it using a while loop because we've done this structure before. It'll be easier. So yeah, you say element to delete. No, before the while loop, you can say element to delete equals top element.
Should I do star? No, no matter what.
Yeah, node star element to delete. So you have two. So in this program, you have two different ways of dealing with the linked lists. Okay, one using a for loop and the other one using a while loop. They're both interchangeable, but they're two different ways. Right. So yeah. Now while top element is not equal to null pointer. Oh no. While element to delete is not equal to null pointer. I'm sorry. Element to delete is not equal to null pointer. And then open brace.
Oh, another.
You have a brace there?
I have one.
Yeah, brace. Oh, I see. Okay, all right, good. So inside, you're going to say I'm going to delete this top element. All right. So node star p equals element to delete arrow next. Yeah. Now you say delete top element and delete element to delete space element to delete. Semicolon, enter. Now element to delete equals p. Okay, semicolon. Now so this structure and put a blank line after the declaration part. So the while loop is separated out. Okay, now let's run this in our head to make sure that it'll actually work. Okay, so what are we doing? We got the top element, and then we're saying that's our P. Our P is equal to, no, element to delete is our top element. Now, inside the loop, we're saying P is the next element of that, and we know for sure it's not null, because if it's null, it wouldn't have got into the loop. So now we're holding on to the next element of the element to delete. Now you can delete the next element, that top element, and make that your next element to delete. Now that'll be in a loop until element to delete is null. Now that should work. Yes or no?
Yeah.
All right. So now you can actually put a comment there on top of the loop, and this loop can be refactored to be more succinct. Have a try it out.
Does it make sense to do the like deletion inside the pop method, because we're already getting rid of pointers there anyways, and then we could just like pop like
Oh, you mean you just do
however many
pop? You
pointers.
just keep doing pop. Yeah. So what Adam is saying is you can also have another
Just
loop.
change this to
No,
pop.
let's not do
Oh,
it that
no.
way.
Okay.
But there's the other way. Let's do it inside of comments. What Adam said, we'll just do it inside of comments. Okay. Yeah. Same thing. Yeah. Same. Yeah. No. While not is empty. While not is empty. While no exclamation mark.
Yeah. Sorry.
Is empty. Yeah. And then on the next line, you basically say pop. Open, close. Yeah. And you can get rid of the braces and everything.
Oh yeah.
Yeah. And then, in fact, you can take the pop. You can take the pop and put it on the same line as a while, right? So while not is empty pop, it's just one line. Space there. Space before the pop. Yeah. Yeah. So that's probably the most succinct way you can do this, right? Because it's just one line and it's all right there. Another way of doing this, okay? You can say another way of doing the same thing.
But then you have to handle like deleting the value at pointers in the pop method, which you should do anyways, because
No,
otherwise.
pop, yeah, pop does, right? Pop will
Does
delete
pop
pointers.
delete? Are we
It
deleting?
should. Otherwise,
Oh yeah, we're good. Okay, yeah, then we just need to pop like until it's empty.
yeah. So that is Adam's way of doing it. You can actually put a comment there saying suggested by Adam, right? Suggested by Adam. Okay, cool, great. No, I think that's basically it. What time is it now? Hey, it's 10 o'clock. Hey, actually, again, it's past class time and all, and all of you guys are still here. That is so cool. So thank you all. I think that's basically it. We implemented a stack, we ran it, we created stuff, we stuck some, put stuff on the stack, and we pulled it out. Does everybody understand how the stack works now, right? And how you can implement a stack using pointers? Now we'll do this again. We will come back to this on Thursday. We'll go back to this exact same program. Maybe Will can share the code on Reddit, and then post it on online GDB and share the link or something like that. And we can come back to this code on Thursday and then play with it a bit more before we try and morph it into something else, or try and play a game with this, right? We'll create a game around stacks. Google, right? So maybe Google in the meanwhile, say interesting games that can be implemented using stacks. Interesting simple games you can implement using stacks, and see if you can come up with interesting ideas. And then we can implement that on Thursday. Otherwise, we'll come up with some game idea on the fly, like we've done in previous classes, and then we'll implement it. And if we don't have any game ideas, we can start implementing a linked list already, because I think I already have a game in mind that we can play for, we can create for linked list. In fact, the game, I'll describe the game. It's a roulette game, okay? So we're going to implement a roulette using a linked list, and also the display with effect method that we implemented a few classes ago, okay? So in fact, when we play the game, we're actually going to see a physical roulette on, on screen. The numbers will actually be running, spinning like that. Okay, and then we'll have arrow marks, say things that, and these are the numbers that, slots in which players place bets. Okay, and then we'll actually be able to see who won, right? And all those things, we'll do the special effects and everything. That should be possible to do in just one class again. Okay, it's all so super duper simple. So that's basically it. So Will, thank you so much for coding and playing along, and your patience and everything, and everybody deeply appreciates. So
don't even know
sure.
It's empty for the destructor, because pop already return. I forgot about this. Pop already returns a bool, so you could just do while pop and then like a semicolon after the.
Oh, yeah. Yeah, that is so cool.
It's already
Please
calling is
do make
empty
that change.
inside pop.
Please do make that change, okay? Yeah,
Pop, pop,
go
pop.
back to the place. Go back to
No,
the
you
place.
don't even now
Go to the
need while pop, just while pop and then semicolon.
no, leave that there. On the next line, another comment. No, leave the whole thing, right? Yeah, triple click that line, triple click the line,
Okay.
and paste it again.
Wait.
Yeah, paste it one more time.
You don't
Two
even have
times.
to,
Paste
if
it.
you don't highlight anything, it just
Yeah,
copies
yeah,
the whole line.
Yeah.
Yeah.
So you can just say while pop, and then semicolon right there. Okay. Pop while pop.
And then you don't need the
Open-
second
yeah.
pop.
That's it. Okay. Now you say another cool way of doing the same thing. And you leave the suggested by Adam and everything there because Adam is the one who suggested this too, right? Okay.
Because pop is only false if it's
Yes.
empty, right? So just check,
Yes.
you don't even need to check if it's empty.
Yes, that's absolutely right. Okay, so these are all really, really cool suggestions, and I'm glad we were able to do this today. Was this class useful? Did you guys learn something new today? Right? Well, I learned something new every class, I hope. But if this was useful, yeah, and thank you very much for your class, and I hope to see you all on Thursday, right? And then we'll try and wrap up stacks, play more with pointers, and get ready to implement the roulette game. Okay, and I think that'll be fun. Well, at least in my mind, it sounds like, looks like it's going to be fun. So the proof is in the pudding. We'll find out. Thank you all so much. Okay, I'll see you in a couple of days. Bye.
Thank you.